some other length units we could have. Yards, feet. Let's just leave it at that. If we are looking at a diagram, typically we are looking at sides. That's another word we could use instead of lengths. If you take a bunch of sides and add them all together, what do you got?
Perimeter.
So that's not. It's another word for length. Distance. Now start thinking specifics. If you look at a circle, what are some segments or lengths that have to do with, I heard circumference, chord, diameter. If you say diameter, what else should you say? Radius. Give me some segments that might come up in a triangle. Altitude? What's another word for altitude? Height. That's pretty good. There could be more. There's lots of names for segments. Anything we talk about having to do with similarity and ratios applies to all of these within similar figures. What is a ratio? Fraction. And what do we use? What type of equation uses fractions? Proportion. So we know when similar figures or solids, three-dimensional figures, show up, chances are we're going to do something with ratios, and maybe we'll do something with a proportion. The example that we're going to look at is this. This is a three-dimensional solid. What is it called? Triangular prism. I'm going to tell you that they're similar. Otherwise, we can't do any of this. So these are similar. Let's draw a little sketch of each one. Here's the little one. Here's the slightly bigger one. Not drawn to scale, obviously. And I'm going to tell you that this length here is 50 centimeters. And this one is 150. We're going to use that model and that example for all three sections. So out of all of my list of things, I used a couple of sides. But I could have easily done a perimeter of a side. I could have called it a height. Could have called it an altitude. A distance, a segment. I'm going to make a ratio. I'm going to take side 1 and put it over side 2. I'm going to get 50 over 150. Always try and reduce things. Okay. This is 1/3. We did this all during the year. What did we call that kind of ratio?
Scale factor.
A little bit louder?
Scale factor.
Scale factor. Write that down. What's the symbol for similarity? Let's put that in between. Put a little similarity symbol in here. Otherwise, this doesn't work and it doesn't make sense. I used side 1 over side 2 and got 1 over 3. If this is truly similar, I could have taken the perimeter of the entire side and then the perimeter of this side and put it into a fraction. I still would have gotten 1/3. Anything within the figures that is a length and uses these units, we'll get a scale factor of 1/3 in this example. Doesn't matter where I look. But when I start looking at area and volume, it won't be 1/3 anymore. What is this called? Scale factor. And what does it apply to? All these lengths, no matter what they are within the figure. If I found this distance right here and compared it to this distance, it would be 1/3. Areas. What kind of units do we use when we're talking about areas?
Volume, no.
And what type of areas have we looked at besides just regular area? What's shown up? Surface area?
Oh, that's a lot.
What else? Lateral area?
Why do you write
Anything that mentions the word area, we cannot look at the scale factor because we're squaring things. But we can use the scale factor to help us find the ratio we want. So I'm going to take side 1 and side 2, and I'm going to square them. Does it have to be side 1 and side 2? Could it be height 1 and height 2? It could be perimeter 1, perimeter 2. They all are the scale factor. So what I'm really doing is square the scale factor, which comes from the lengths. In this case, we have a 1 and a 3 that are being squared. What's 1 squared? What's 3 squared? 9. So the ratio of the areas of my two similar figures are not 1 to 3, they're going to be 1 to 9. Does it make sense? We have units that are to the power 2, our ratio is to the power 2.
Do you have to memorize these formulas?
What formulas? You mean squaring? Yeah. All one of them. You have to, all one of them you have to. Next, a three-dimensional shape also has volume. What words do you think of when you see volume?
Meters cubed.
Meters cubed. Water, liquid. How about fill, inside, space. Our units are to the third power. Make a deduction here. How do we find a volume ratio? What do I cube? So, cube the scale factor. In our case, and in most cases, you're going to use sides to do that. So I'm going to take side 1 and side 2, and I'm going to cube them. You can either take the exact sides, or you can take the reduced scale factor. I'm choosing to use the reduced scale factor. 1 cubed, 3 cubed,
27.
What is that? Ratio of the volumes. So if you compare the volume numbers, they're not going to be 1 to 3, 1 to 9, they're going to be 1 to 27. Much different than just the scale factor. So what powers did we use from the scale factor? Squaring and cubing. What if I had to go backwards? What if I had this and wanted the scale factor? How do you uncube it? Cube roots. Cube roots. How do you unsquare it? Square root. Which leads us to why we are getting these. We are getting these